I'm leaving in 20 minutes.
Why do you come to class? You come to class.
Why do you have to work? Because my boss scheduled me to work at 3, and in order for me to get home and get dressed and get ready for work, I have to have enough time to get to work.
Why don't you just come dressed?
Come dressed for work to school?
Could have done that.
No, because my uniform is really simple.
So, who cares? I have 4 or 5 people in here, and one of them knows you.
Shit. Emily's gonna walk me like, what the hell are you wearing?
Good afternoon, madam. Can I take your order?
Okay.
I don't work at McDonald's.
You look like a busboy. That's what you.
Sadly, this starts with a picture. And the picture is going to lead into algebra. And the algebra is going to be what gets us messy. But at the end of it, it turns out to be really nice. And it's the thing you need to memorize. I just want to show you the algebra because you all forget about it.
So, addition and subtraction identities.
Mm-hmm.
I'm going to draw this picture first.
Some difference of the identities. So the first thing is this is a unit circle. And if it's a unit circle, it has to follow this formula, where x squared plus y squared is equal to 1. And all I did was throw 2 angles in here, one in the first quadrant, one in the second quadrant. And I called the smaller one the acute one beta, and I called the bigger one alpha. And I gave them coordinates on the unit circle, x1, y1, and x2, y2.
Doesn't x2, y2 actually have certain coordinates?
Nope, no specific coordinates. It could be any angle, any coordinate on the unit circle.
Fishy. I drew a fish.
So the one thing I want to find here is the length of that chord. Remember, chords on a circle are between 2 points inside of a circle. A diameter is a fancy chord. It just has a different name. So how do I find the distance of that chord? The length of it?
Alright, and now I have, okay, ask the question again.
How do you find the length of that chord?
The distance formula?
And the distance formula is?
I don't remember.
You don't remember.
No.
I write it shorthand.
Alright.
Do you remember what the little triangles mean?
Difference.
Difference, change. So you subtract your x's and you square them, you subtract your y's and you square them, and that becomes the distance after you square root it. All right, so what's the distance between p alpha and p beta? Well,
We need actual numbers, don't we?
nope. We're going to do it all symbolically. Yeah, it's going to get crazy. So what's the change in x?
x1 minus x2?
Yeah, we can do it that way. It doesn't matter, though. You can do it the other
Because
way,
when you
too.
square it, it gets positive anyway.
Don't think that. It's depending on what the answer is.
Isn't the distance supposed to be a positive number, though? Because it's a
Yeah, but you're thinking that minus sign in between is becoming positive, aren't you?
No, the minus sign is if the x2 is a bigger number than x1, it can
Good.
become
Now I
negative,
agree with
but
you.
when you square it, it's positive.
I agree with you now. I
That's
was
what I was
worried
saying.
that you were going to say, oh, just change it to a plus.
Challenge
No.
the status quo.
Plus, what's the change in y then? Well, y1 minus
It's the same thing as x.
y2 squared.
Plus.
Okay. So that would be the distance of that chord. So here's what I'm going to do to my picture. I'm not going to redraw the whole thing. I'm just going to draw a portion of it. What I want to do is I want to take that triangle formed by the black, the green, and the blue line, and I'm going to rotate it so that this point rotates right down on top of 1, 0. But I want to keep the length of that chord exactly the same. So as I rotate it, basically it's just a piece of pie and you're moving, or a pizza, it's a piece of pizza, and you're just moving the piece of pizza so it's in a different orientation.
I like pizza.
So the beta line now becomes this, and it hits this point 1, 0. So in that case, the angle just became 0. The alpha line segment there is someplace in the first quadrant now. It's probably too long. Right about there.
It's just somewhere there.
Yeah, as long as the chord is exactly the same, the angle in between them is going to be exactly the same.
Hey,
And here's my chord.
Ryan. Don't you remember that equation, that second equation that equals d from algebra?
This one here?
It's the distance formula.
Yeah.
That's the distance formula.
It's the same thing as the top one, dude.
Yeah, I know.
It's just differently
You just
written.
lengthened it.
Yeah. Expanded.
I'm the one that said what the distance was.
You want some?
We're going to call this one just plain old P, and it's going to be coordinates x3, y3. So basically all I've done is taken this triangle, rotated it down, so the green line hits the positive x-axis, and the black line follows exactly behind it.
Okay, wouldn't the black line end up where the green line used to be?
Not necessarily.
So
If it was a really thin angle, it would end up actually closer to the x-axis.
Oh.
Where if like beta was really big and alpha was a little bit smaller, it would be a very thin angle. So what's the measure of this angle in here?
isn't it the same one as beta?
Beta only brings you up to the green line. Alpha brings you all the way to the black line. What's the angle in between them?
It's beta plus x.
Nope.
It's a number?
If alpha was 100 and beta was 20,
That's 80?
that would be 80. What did you do to them?
We subtract them.
So it would be
You find the difference.
It's alpha minus beta.
alpha minus beta. So this angle here is alpha minus beta. Okay. So what is the distance of this line segment here from regular old P to 1, 0? Well, that would be the distance is equal to the square root of, what's the change in x?
X3 minus 1.
x3 minus 1, you'll square it. Change in y,
Y3 minus 0.
y3 minus 0, better known as just plain old y3. Okay, so that's the distance of the blue line. This other one was also the distance of the blue line. So these two distances must be
The same.
equal. So we're going to set them equal to each other. Oh, and by the way, since I'm setting two square roots equal to each other, what can I do with the square roots?
I cancel out.
I can just drop them. So this one
Pick up the-
Yep.
is x1 minus x2 all squared plus y1 minus y2 all squared is equal to, well, that one down there, x3 minus 1 all squared plus y3 squared.
Okay, give me 1 second.
That rows
So equal to x3 minus 1 plus just y3 squared.
All right, ready?
Yeah.
Now the fun. Expand the first one out. What's x1 minus x2 all squared?
X1 squared,
x1 squared.
some number.
Four.
Isn't it going to be minus?
Minus.
Um,
If you're foiling, it would be x1 times x2 and then x2 times x1.
so it's 2x1, x2.
2x1, x2.
I was right.
Wow.
I really just guessed on that one.
That's good.
Holy shit.
You
Keep
were
guessing.
guessing.
Keep guessing. Plus.
X2 squared.
Yeah, x2 squared. What about the y ones? Well, the y ones are going to follow the same thing. So you're going to get y1 squared minus 2y1 y2 plus y2 squared. On the other side, you're going to get x3 squared.
Minus 1.
Give me 1 second. Hold on.
Plus 1. Because negative times a negative is a positive.
It's
That
minus
was the
2.
last number.
Minus 2.
Minus 2
X3.
x3
Oh.
Yeah, John. Plus
So-
1.
plus
Yeah.
1 plus that y3 squared.
Yeah.
Okay. And the only reason I like showing this is it looks horrible.
Yes,
It
it
does.
does.
But then, this is the beauty of math. You can take something that looks absolutely horrible and simplify it if you look at it the right way. Like, for instance, here's an x1 squared, here's a y1 squared. What's x1 squared plus y1 squared?
1.
1, because we're on a unit circle, so x squares plus y squares are always going to equal 1.
Okay,
So there's 1. Here's a x2 squared and a y2 squared. So
That's
that's also going to
one.
give me
1.
plus 1. I can't do anything with the other two, so negative 2,
There's an
x1,
X3 squared and
x2.
Y3 squared.
Yeah, we're getting there. 2y1, y2. Other side of the equation, this one and this one become
1.
and 1 plus this one is
2.
so you get 2 minus 2x sub 3. So a lot of the junk that we expanded out,
How did you get 2 minus 2?
this is 1, here's 2.
Oh, I didn't see the one in the middle. I'm sorry.
This one right here.
Because I missed that. There were literally so many numbers next to letters. I missed that one.
I know, and that's so easy to do, it's funny. All right, so I have 2 on this side and 2 on that side. What happens to the 2's?
They cancel.
They're going to cancel. So this goes with those 2. If I subtract 2 on both sides of the equation, it becomes 0.
Yep. All right.
What's left over is everybody has a negative 2 involved.
You can factor that out, can't you?
I can divide it out.
Oh,
Divide
same-
both sides
same
by
thing.
negative 2.
Same thing.
So if I divide by negative 2, I get x1, x2 plus y1, y2 is equal to x3. Okay.
All right. So now what?
Now we go to interpretation. What does it mean to be x1? It's on a unit circle, and it's the first coordinate.
Does this go back to sine and cosine and stuff?
What's x1 represent then?
Cosine?
Cosine of
Why?
the angle.
I don't know.
What's the angle?
Cosine of theta.
There's no theta.
Alpha?
Alpha.
Cosine of
So x1 becomes cosine of alpha.
Alpha.
Y1 becomes
Sine of
Sine.
alpha.
sine of alpha. X2 becomes
Cosine of beta.
and
Sine of beta.
it's sine of beta. And then over here we have x3 is alpha minus beta. It would be the
Yes.
cosine of alpha minus beta. So where you see x1, this turns into cosine of alpha. x2 is cosine of beta plus y1 is sine of alpha. y2 is sine of beta. x3 is not the answer.
Is
X3 is cosine of alpha minus beta.
Cosine of alpha minus beta. So this becomes cosine of alpha minus beta. So this is the difference formula. It's usually
I'm gonna do adjectives.
There is no special triangle for cosine of 15 degrees, because the only things we have available are, and yes, you still have to know these, the 30, 60, 90.
I forgot like the length sides on the test.
Yes, I know.
yeah. And then a 45, 45.
That one was easy to remember. I forgot the 36 and 91.
Yeah.
45, 45.
Yeah.
So how am I going to get cosine of 15 using these two pictures? Well, you can't.
You have the first one.
If we knew a half formula, I haven't taught the half formula to you, all we have available to us is...
Wait, so there is a half
Well, there is a half formula.
Yes.
That
So
you can't
me
use.
guessing completely out of the blue, just it was kind of right. At the same
We're
time.
getting there, yeah.
Awesome. I'm so
But
smart.
let's try using the one we have available
You
to
should be
us.
the investigator.
I have the cosine of alpha
What
minus
is
beta.
that?
So what two angles can I put in the alpha beta here that gives me 15? In other words, what angles can I subtract to get me 15?
45 and 30.
45 and 30, 60 and 45, 90 and... No, 90 is not going to work. So either of those will work. Either of them will work. So which one do you want to do? You said...
45 and 30.
So this would be cosine of 45 degrees minus 30 degrees. Now this has to be equal to that. You cannot change that. Otherwise you'll be finding something really strange. So by the identity, it's this pattern. So you're going to do cosine of the first one, cosine of the second one, change the sign from minus to plus, and then sine. So this will turn into cosine of 45, cosine of 30, plus sine of the first one, which is 45, sine of 30.
Okay.
And each one of those we can calculate out. What's this cosine of 45 rationalized?
So, before you continue,
Okay.
when you did cosine of 45, cosine of 30, plus sine of 45 plus sine of 30, you really just took what you had at the top, the 45 minus 30,
And
and
used our
distributed
identity.
evenly to those.
And did our identity. Don't think of it as distribution.
You put the 45 and the 30 where the alpha and beta.
Alpha and beta are substitution.
Okay.
So the pattern is if you have cosine of a subtraction, it's cosine, cosine, sine, sine with a plus.
But that's just for cosine, isn't
That's
it?
just for cosine.
Is there a different one for sine?
Yes.
Investigator.
We should be curious about your homework too.
Watch
So
this.
what's the cosine of 45?
That's the calculator.
Some old hippie caught another hippie tripping on acid.
Oh, wait, hold on, there's right there.
Jeez, I have a picture. So what's the cosine of 45?
It's 1 over 32.
bottom 1 over square root of 2, but we're going to write it as,
Square root of 2 over 2.
and here you do have to rationalize, where before I didn't care, here you're going to have to. What's the cosine of 30?
Square root of 3 over 2.
Square root of 3 over 2, adjacent over hypotenuse, plus sine of 45.
2 square root of 2. Square root of 2 over 2.
Square root of 2 over 2. And sine of 30?
1 half.
1/2. Opposite over hypotenuse.
So now you multiply them and then you add them?
They're going to have a common denominator because 2 times 2 is
Okay.
4. So you only have to worry about the top. Square root of 2 times square root of 3 is?
Wait, ask that again.
Square root of 2 times square root of 3.
Are we supposed to know that, or is there like calculate?
Square root of 2 times square root of 3.
Square root of 6?
Thank you. Boy.
Oh my god, I'm so good at guessing.
Yeah. That's not a guess. That should be something you know.
I did
Square root
know.
of 2 times 1.
Square root of 2.
Okay. All over
4.
4. So the cosine of 15 degrees is equal to the square root of 6 plus the square root of 2 all divided by 4.
Yeah.
Then you can type it in your calculator and figure it out.
Yeah.
Of course, you could have typed in cosine of 15 degrees and got a decimal answer to begin with.
So if we type in square root of 6 plus square root of 2 all divided by 4,
You'll
it
get
will
what your
equal
calculator.
whatever that is.
Yes. Whatever your calculator.
Couldn't we have just
spits out.
did the cosine of 15 degrees in the calculator?
Yes, you could have.
So why did we have to know this? If we could just use the calculator?
Oh, there's other reasons to do it, but before the calculator, how did you figure out all these things?
You guessed.
No, you did not. They came up with tables. But then you have to ask, well, your calculator does trigonometry really strange. But before that, there were tables, and to come up with all the tables, they used all these identities to come up with all the possible different answers. Of course, the more powerful one is the half one. I think it starts off this way. I want sine of alpha.
Is it plus?
Plus beta. I think this is the way I want to start.
Oh my god.
Don't be quiet.
I guess plus equals plus.
You should become a psychic. That's what you should become.
So much SVU.
What is this equal to in terms of cosine?
Psychic would be
Trick question.
a Big Bang Theory.
What is the relationship between sine and cosine? What are they
When
called?
they're divisible, they're reciprocals.
No.
Fancy name. They're called cofunctions.
Yep.
And the relationship between cofunctions is if I have sine of an angle, it's equal to cosine of. You don't remember, I bet.
Another
Pi over 2 minus that angle.
You see, I remember you writing that. I just don't remember if that was the answer.
Yeah.
So sine equals.
Remember we were in a triangle and I said, well, here's theta, and if I want to find sine of theta, it would be A over C. And if I wanted to find cosine of beta up here, then it would be A over C. So these two angles are complementary. So it ends up being this neat little formula. So I can do that here. So this would be pi over 2 minus alpha plus beta. So sine of alpha plus beta is equal to cosine of pi over 2 minus alpha plus beta. We can rewrite this as the cosine of pi over 2 minus alpha as the first angle minus beta. So far, so good.
I guess.
As long as you agree with my original S.
I'll agree with whatever you say.
I mean, I could prove it for you if you want.
I'm fine. I got like 5 minutes.
All right. So if we expand this using the formula, it becomes cosine of the first angle, cosine of the second angle, plus, because this one's minus, sine of the first angle, sine of the second angle.
Okay.
So that's just the regular old cosine identity. But what's cosine of pi over 2 minus alpha? Which is
Sine.
sine. So this becomes the sine of alpha times the cosine of beta plus, what's the sine of pi over 2 minus alpha?
Cosine?
Cosine of alpha sine of beta. And then drop this guy down, so you have the sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta.
Yeah. What he said.
Now, I usually don't write it in that order. I write it this way.
I think I'm doing this. I'm ready to finish.
I like this order better.
The drum lights.
I don't know why.
Wait, what did you do?
I just took the last two and flipped them. I like saying sine,
Oh, so
cosine,
they
sine,
match up.
cosine.
Oh,
And then be careful, it has to be alpha beta, then beta
Alpha.
alpha. You don't want them to be exactly the same as you go across.
let me switch this one.
Now, out of all the identities I'm going to teach you, these four, I've already done four, you didn't notice it. Cosine has two of them, and sine has two of them. For instance, I didn't show you this earlier, but if I made this sine of alpha minus beta, what do you think changes?
The order.
Nope, order doesn't matter.
The minus.
Yeah, the plus here becomes
Yeah, it becomes minus.
a minus. So this would just be sine of alpha, cosine of beta, minus cosine of alpha. Oh, darn it. I was looking up here.
Yeah.
Sine of beta, cosine of alpha.
So why over there on the left when it was minus to begin with, you
Oh.
put plus?
This one over here,
Yeah.
cosine's pattern is if it's minus on the inside,
It's
it's plus on the outside.
So if it was plus on the inside, it's minus on the inside?
Right.
Yeah.
Why is everything like the opposite, but that is like the same?
You'll find that cosine is always opposite and sine usually stays the same. It's really strange.
Welcome to life.
It's just the way things are.
Yeah.
I used to be so good at math, and now I hate it.
Oh. It's just trigonometry. It's just more stuff to remember. Ah.
You might as well just go ahead
You might as well just give up.
and hit the eject button.
Eject. Did that. Did that. All right. So how about finding, strangely enough, sine of 5 pi over 12?
Score.
Make it bounce.
So
If it bounced off the wall into there,
that would have been cool.
I would have been like, I'm doing.
Now, before it was in degrees, it was really easy to see what to do, but now it's 5 pi over 12. I'm going to give you a hint. Write out your angles. Zero's not going to do us any good. So pi over 6, pi over 4, pi over 3.
Here's your question.
And if you want, pi over 2.
Do you draw a picture?
Not necessary. First time ever, right?
Yep.
Well, I didn't draw a picture for those either.
Text me the homework.
Yep. Have fun for 6 hours.
Text him the homework that he's not going to do.
And then clean the popper.
No, that's not me tonight.
Where's he going to work?
He works at the movie theater.
Right? I don't have to go there and pick on him. Which one?
The UEC.
Over there?
Yeah.
You working tonight?
Yeah.
Is there any good movies?
He's working 3 to 9.
Any good movies?
American Sniper is gonna be a good movie. I want to go watch that one. Kingsman. Kingsman's funny.
Yeah, I might want to go see that. So here's the trick. Change all of these into pi's over 12. So what's pi over 6 as a pi over 12?
What's pi over 6 as pi over
How do you
12?
change pi over 6 into something out of 12?
You multiply?
Top and bottom pi?
2.
2. So this becomes
2 pi over
2 pi over 12. This one becomes?
3 pi over 12.
Yay.
And 4 pi over 12. And 6 pi over 12.
Now, out of those pairs, is there any of them that add or subtract up to 5 pi over 12?
2 and 3 pi.
2 and 3 pi. So these are the two
Yeah.
you're going to choose.
Yeah.
Does that make sense? Because I need that common denominator to come up with 12, and I just only know add and subtract. So I'm going to choose these two. I'm going to use addition. So I'm going to change this into sine of, and it doesn't matter about their order, because we're adding them. If we were subtracting them, it would matter, and you get that. Now, 2 pi over 12 is the same thing as pi over 6, and 3 pi over 12 is the same as pi over 4. So this is going to turn into sine of the first angle, cosine of the second angle, which is pi over 4. And with sine, the sign doesn't change, so you get plus sine of the second angle, cosine of the first angle. All right. Sine, cosine, cosine, sine, angle switched. Okay. What's the sine of pi over 6? Do you know off the top of your head?
Because we're doing the special.
Always. Always those special triangles.
Sine of 30 degrees. 1. That's 1, 2 square root of 3. But sine is
Some old hippie.
opposite over hypotenuse.
So that would be
1 over 2.
1 over 2. I've seen people do weird things here. I've seen people write sine of a half,
Ouch.
which is really messy because sine of pi over 6 is a half. So make sure you do the pure substitution. What's cosine of pi over 4? That one you should memorize.
45. That's 1 over. That's square root 2 over 2.
Square root of 2 over 2. Sine of 45.
Square root of 2 over 2.
And cosine of pi over 6.
Square root of 3 over 2.
And it looks really similar to what we did before.
Yeah.
So this becomes the square root of 2 plus the square root of 6 all over 4. That's 5 pi over 12. That's
5 pi over 12.
each pi over 12 is 15 degrees, so 15 times 5. 75? So this is sine of 75 degrees.
Okay.
Sine of 75 degrees. Which is exactly the same as cosine of 15 degrees.
Yeah.
And 15 and 75 add up to
90.
90. And it goes back to that law of pi over 2 minus the angle. All right. Identities with these. Example. Cosine of A minus B over sine of A sine of B is equal to cotangent of A cotangent of B minus 1. What side should you play with?
The left side.
Left side. Right side, you're used to playing with it because there's 2 terms, but it would be really hard to change it into a difference of an angle.
Yeah.
So what's cosine of A minus B equal to? It's that formula that I gave you earlier. Cosine of? Take a guess. Cosine of?
Cosine of. Okay. Blah.
Yeah, I'll give you
Cosine
that.
A minus cosine B?
Nope.
Oh.
Did you write it down? Cosine of the first one, cosine of the second one. That first formula I gave you. From the distance formula, it popped out.
Oh.
Cosine of A minus B, alpha minus beta is equal to cosine of A.
Okay, so what would be cosine of B?
Cosine of B.
Oh, was it?
I was
Oh,
close.
I didn't hear him.
Yeah.
Oh, I'm sorry. And the minus becomes
Positive.
plus, and then you get
Sine of A and sine of B.
sine of A, sine of B. I'm used to him mumbling. I heard him mumble it. And in the bottom, of course, is sine A, sine B.
What a mumble if she heard it.
I have bad ears. I'm old. I'm old.
Yeah, that's the excuse.
I'm old. Now what?
You get rid of the. You have sine of A and sine of B on top.
Yeah,
On
yeah.
top and bottom, so you Get rid of it. You divide it out, right? Or what? I can't or something.
I'm
Yeah.
curious, if you have x plus 2 divided by 2, can you just get rid of the 2's?
No.
No. Same reason. There is something I can do, though. If I had 4x plus 2 in the top, I could write this as 4x over 2 plus 2 over 2.
Yeah, you separate them. So cosine A, cosine B over sine A, sine B, and then sine A, sine B over sine A, sine B.
Over sine A, sine B, plus sine A, sine B, oops, over sine A, sine B. If anything, you have to write these really quickly and accurately, so your brain doesn't go to a stop. Because if you concentrate on the writing, you're going to forget why you're writing it. All right, what's the first one turn into? All right, how about this? What's the second one turn into? That's the easier one. Sine A, sine B over sine A, sine B becomes 1. What's the first one turn into? Well, I can separate these also because it's multiplication. What's cosine of A over sine of A? Cotangent. So that would be cotangent of A. And cosine B over sine B is cotangent of B, which is the other side.
Yeah.
Except for one problem.
You have a plus.
Maybe my notes are wrong.
You got your notes wrong.
Seriously, I got my notes wrong. Plus, don't do this on the test.
Yeah.
I actually do have my notes wrong. It even shows one has plus and the other one has minus, and I stopped. And we are done, is what I said. So if I want a formula for tan, let's say alpha plus beta. I don't want to go drawing more pictures and doing more math. So is there anything I know about tangent that'll help me get to a identity in terms of tangent? In other words, what's tangent equal to? Sine over cosine. So I can rewrite this as sine of alpha plus beta divided by cosine of alpha plus beta.
Yeah.
All right. But we have identities for sine of alpha plus beta, which is?
Yeah.
These are the ones you have to memorize. Sines and cosines of differences in subs. I don't ask you to memorize the tangent one. I'll give that to you on the test. But what is sine of alpha plus beta?
Sine of alpha.
Sine of alpha,
Cosine of beta.
cosine of beta,
Sine of beta. Cosine of alpha.
all over.
Over.
Cosine of alpha plus beta becomes? She's cheating. I'm supposed to memorize it by now. No, go ahead, cheat.
Yeah. Cosine of alpha. Cosine of beta. Minus sine of alpha. Sine of beta.
Look at that. Now here's the trick. I want this in terms of tangent, not in terms of sines and cosines. It's perfectly fine the way it is. It's just too much. So is there any way I can create a tangent out of all this mess? Remember what tangent's equal to?
Sine of cosine.
Sine over cosine. The problem is there's a plus and a minus in the top and the bottom. So I'm going to have to go through and divide everything by something. So I'm going to write sine of alpha over cosine of beta over something plus sine of beta cosine of alpha over something. And then cosine of alpha cosine of beta
Minus.
over something minus sine alpha sine beta over something. Now I just got to choose what to divide by. Ooh,
Complex fraction.
we're going to create a complex fraction out of this mess.
Yep. Ouch.
There. All right. So what do I want to divide by? Well, I want to divide by something that forces things to turn into tan alpha and tan beta. So I want to make sure that sine stays in the top and the cosine shows up in the bottom. I don't want to leave cosine behind. So guaranteed I want to divide this fraction by I want to keep the sine, but I want to get rid of the cosine.
Divide by sine.
If I divide by sine, I get rid of the sine.
You said you want to keep the cosine.
Mm.
No, you want to keep the sine.
I
So
want
you
to keep
divide
the
by
sine. I want to get rid of the cosine.
So you
I
divide
want
by cosine.
cosine beta. So put cosine beta in the bottom.
Then
Over here, I want to also get rid of cosine of
alpha.
alpha. So let's try dividing everything by cosine beta, cosine alpha. Let's see what happens. So cosine alpha, cosine beta, cosine alpha, cosine beta.
That's going to get rid of your entire bottom. Or, well,
Parts of it.
part of it. It's going to get rid of half of it.
But the goal is I wanted tangent out of this mess, so I definitely had to get rid of the cosine in the top of the first fraction and the cosine alpha in the fraction next to it. And that kind of forces my hand for all of the fractions. So after doing that, what happens to the cosine betas is they go away. The cosine alphas go away. This whole thing turns into that one. And then over here, you get tangent and tangent. Okay. So sine alpha over cosine alpha is better known as
Tangent alpha.
tan alpha. Plus sine beta over cosine
Tan
beta.
beta.
Tan beta.
Over.
Over
1
minus
minus
tan alpha
tan beta.
times tan beta. So this becomes the formula for tangent of alpha plus beta. What do you think the formula for tangent alpha minus beta looks like?
Opposite.
You'd have to take the opposite of everything. The
Yeah.
top becomes minus, the bottom becomes plus.
Yeah.
So this is one of the formulas, the first one that I'm going to give you on the test. I'll just give it to you. It'll be a nice long formula sheet with everything on it. Half angles, double angles. Yeah, there's lots of fun stuff
Okay.
coming up. All right. Now, I don't ask a lot of identities with this stuff, but I do ask these weird questions. For instance, given the sine of alpha is equal to 3 over 4, and alpha is in Q2. Cosine of beta is equal to negative square roots of 5 over 5, and beta is in Q3. Find sine of alpha minus beta. That's the type of question I ask. Why? Because it goes back to the last test. The one y'all did really well on. Yeah. So, what do I do? Well, I can start off with what the heck is sine alpha minus beta. So it's sine of alpha, cosine of beta, minus sine of beta, cosine of alpha. Do I know any of those?
Yes.
Yeah, I do. Sine of alpha I know, that's 3/4.
Yeah.
And I don't know this one. Minus, oh, I do know
you
cosine
do.
of beta.
Cosine of beta.
Negative square root of 5 over 5.
Yep, you
But
don't know the
these
rest of
two, I don't know. So how do I find those two? What do you think I should do? The sine of alpha is equal to 3/4, and alpha is in quadrant 2.
Draw a picture.
Draw a picture. So you draw a picture here. Always draw a picture for this job.
Yeah.
And the angle's in quadrant 2. Should I finish my picture? How do I finish it?
Well, by making it a triangle.
Make it a triangle straight down. Do I know the sides? Yeah, so where's the 3 go?
Let's see, this is sine,
Sine of alpha equals 3/4.
which is opposite of
And if this is my reference angle for alpha, opposite would be
right there.
there. Hypotenuse would be
4
here.
square root of 2.
No.
No.
No. How do I find the third side?
Let's see.
C squared equals A squared plus B squared. C is
20.
C squared,
No,
maybe?
16.
16. A squared is
9.
plus B squared. 16 minus 9 is?
7.
So B is equal to?
Square root of 7.
So this side is square root of 7.
Yeah.
Just square root of 7?
No.
Negative.
Negative. So negative square root of 7. All right, now that is the picture for alpha. Do I know the cosine of alpha now? What's the cosine of alpha?
Yeah. Which is adjacent over hypotenuse, which would be -7/4.
Negative square root of 7.
Oh,
So negative square root of 7 over 4. Yay!
Yeah.
That's part of it. What do I have to do to get the sine of beta?
Negative square root of 7 is 3.
No, I have to draw another picture.
Another picture.
Because beta has nothing to do with alpha.
Oh, that's right. It's a beta.
Yeah, beta is up here. Cosine of beta is equal to negative square root of 5 over 5. And it's in the,
Third quadrant.
so I have to draw a triangle here back to the x-axis. This is my reference angle for beta. Where's the square root of 5 go? It's either going to be on the top or the far left. Top or far left? Cosine.
which is adjacent over hypotenuse.
Top or far left?
Oh, top.
Top. Negative square root of 5. Where's the 5 go? Left?
No,
Hypotenuse.
right
Yeah. What's the third side?
there.
You want me to go through it? Hypotenuse is 5, so that'd be 25. If I square root the square root of 5, it becomes
5.
5.
Negative 5. Whoa. Oh, yeah. You have to.
It's squared, it always becomes positive.
Yeah.
Move the 5 over, you get b is equal to the square root of 20. Therefore, this is 2 square roots of
10. No, 5.
5, 10. So this side is 2 square roots of 5. Is that right?
Maybe.
What should I add?
Negative.
Because it's going
Down.
down. So this one, if I'm going to do the sine of this angle beta, what does it become?
-2 square roots of 5
Over
over 5.
over 5. And then all I have to do is simplify.
Yep.
The denominator is going to be 20. 4 times 5.
Yep.
So all I have to do is put a 20.
Yep.
Longer line. You can see yip all the time. 3 times negative square roots of 5 is negative 3 square roots of 5. Negative times a negative times a negative for the next 3. What's a negative times a negative times a negative?
A negative.
A negative. 2 square roots of 5 times square roots of 7.
$35.
So I just write 35.
It's square. Wait, no. I was. Whoa.
2
Square root of
roots
35.
of 35.
Yeah. I
So
was,
this would be
I was thinking there were squares in there.
the sine of alpha minus beta.
I might have just like, please get rid of the
Radical.
radicals.
You can't. Sadly, this part of the book, the radicals get worse.
Exterminate the radicals.
They get radical. Radicals.
Rad rads.